So yesterday we talked about specific kinds of parallelograms, rectangles, rhombuses, and squares. We said that a rectangle is a parallelogram that has 4 right angles, a rhombus has 4 congruent sides, and the square is the combination of the two. In addition to those things, we learned that rhombuses have perpendicular diagonals and diagonals that bisect opposite angles, and then rectangles have congruent angles. So now you have all those properties would also be true for a square. Number 1 and 2 are just asking to name the quadrilateral for which the statement is true. So number 1 says both pairs of opposite angles are congruent. And that says angels, but it should be angles. Which of these would that be true for? All of them, because it is a parallelogram, right? It's for a parallelogram, and a rectangle is a parallelogram, and a rhombus is a parallelogram, and a square is a parallelogram. So it's true for all of them. Number 2, a quadrilateral is equilateral. So which of these, and it's which of them does it have to be true for, not can be true for? So Mars.
It has to be true for a square.
And a rhombus.
Oh yeah, rhombus, yeah.
Questions on those? All right, question 3 says, given rhombus MNOP, find angle NPO. So NPO is this angle here. It would be what? Go ahead, Mars.
It's 48, but I have a question for the previous question.
Okay, hang on. So it's 48. Why?
Because on rhombus, the opposite angles are congruent.
They are congruent and
Diagonals.
they are bisected. So these would all be the same. All right, 4, given rectangle QRST, find the measure of angle RUS. How do I find it? Come on.
Bro.
It would be 90 if this was what? A square or a rhombus? Jonathan. Why?
Because 26, because TRS equals 26 because of opposite interior.
TRS equals 26 because of opposite. Wait, TRS here?
Yeah, there.
How'd you get to that?
Or RST 26.
Wrong.
No, it isn't because RS and QT are parallel.
Actually,
It's a
supposed to do
rectangle.
Right,
we
so-
have 20, or, okay, 90
I'm not saying you're wrong. I'm saying how you're getting there is not working. So give me, what'd you just say? Hang on. Shh, shh.
Let him explain.
Go ahead.
90 minus 64 equals 26. So
Which is where?
SQT, which is the missing.
SQT. This angle here. Okay, so now we're getting somewhere. So this has to be 90. So this is 26. Okay, now go.
RST equals 26, the smaller one, because opposite interior.
Okay.
So, and I know that 26 or RST equals the one that's there.
Why?
Because I know that they have to equal 180. So I can. So,
But how do you know? You're not wrong. These are congruent. But why? You just think they're congruent. Yeah. Okay, but what kind of triangle? It's an isosceles triangle. Why is it an isosceles triangle?
I have an answer for square.
So the angles are congruent.
So it's isosceles because the sides are the same, these two sides. But why are those two sides the same?
I have the
Yeah.
answer. All the angles equal 90.
Nope, go sides.
Wrong.
Because they
Oh wait, no, that's
What's true about the diagonals?
They don't bisect.
They
They bisect each other and in a rectangle,
all of them are equal.
they're congruent. So all of those are congruent, which means this is 4 isosceles triangles. Do you understand that? Yeah? So this is the same as this, but this is also the same as this, which means this would be 64, right? Like you could build each of those triangles as 4 isosceles triangles to the same. This would be 26 and 26. This would be 64 and 64.
Do they not all equal 90?
They do, what do you mean all equal? Each triangle?
All angles.
Yes, in each individual triangle, they would add up to 180, but they don't have to add up to 90. The corners have to add up to 90.
Yeah, the corner angles.
Yes, which is how we got the 26 to begin with. Does that make sense? So you had to use the 90 degrees to get to the 26, but then the fact that these are isosceles triangles is what allows you to get that the other angle would be the same, which is 26. Add those together. 26 plus 26 is what?
26 plus 26
52, and then subtract it from 180 because that's what the angle that we're looking for. And you get 128.
I feel like what I did was easier.
It might have been because that was pretty. What did you do?
64
Yeah.
on the other thing, and then I knew that I added up to 180, so I added 64 to 64, and then I subtracted.
To get this angle here at that angle.
Yeah. and
Yeah.
then-
She's not giving me.
And then I knew that it was supplementary, so I subtracted that from 180.
But
But
why?
I just knew that it was.
She's not giving me.
Wait, sorry. Oh, you just did the other angle there. Did you do this work or did you just know that this would be the same as that? Because you can also use the exterior angles on that one. Yeah. Yeah. So you still are, it's still that you know that they're isosceles, that this would be 64 and 64. So that still works, right? You didn't even need the 26. Add those together, subtract them from 180, and you get 56 for this angle. And, or sorry, 52 for that angle. 52. And then subtract it from 180 because those form a linear pair, and you get the 128. So obviously there's way more than one way to do these things. They should, all those properties should overlap. But you definitely needed to know that in every rectangle, it's 4 isosceles triangles because you have diagonals that are congruent and bisected. Yeah.
Why would you need to subtract 180 from 128 and then subtract 180 from 52?
Well, she just said basically that if you know that they're both supplements, which they would be, you wouldn't need to do that, but that is the work. Like if you remember that two angles that are supplements to the same angle, they are congruent, then you could go straight to the 52 on the other side.
I got it.
But you have to take the 52 from the 180 if you got the 52 here and you're looking for the 128. Like you can't leave it at the 52. The answer should have been 128. I'm like scared to ask, but did anyone else do it differently? Because I'm sure that's not the only way, but those both did work.
No.
Okay.
I did do it differently.
But did you get it right?
Oh my god.
Yeah, I got it right.
Oh, okay.
He doesn't have to explain it.
He can though. Thank you though. Thank you, assistant teacher.
However, I did not realize that you have to do more work because I knew that I thought that since all the angles equal 90, then and all the diagonals are bisected and congruent and whatnot, since that bottom left angle equals 26, then the other bottom right angle equals 26, right?
Yeah.
And then you just subtract 52 from 180.
So you did it in the
And then
triangle
vertical
format.
Angle, yeah.
Yeah, that's fine.
Originally in this lesson.
All right, 7.5 is properties of trapezoids. So this is the last section in the chapter. This is the last of the sections that'll be on your Tuesday test. Okay, which means this is also the last section until
So what?
until 2023.
Hurrah.
After your test, we'll start reviewing. Yeah.
I'm so happy.
Okay, so we're going to learn about 2 more quadrilaterals, which are trapezoids and kites. So by the end, we've got the big family of polygons, then you get your quadrilaterals, then you get your parallelograms, then you get your rhombuses, your rectangles, your squares, and now we've got trapezoids and kites. So these are not parallelograms. They are on like if we're going to draw, which we will, draw a Venn diagram at some point with including these. They would not be parallelograms, so they don't have the same qualities that all of the rectangle, rhombuses, and squares have. A trapezoid is a quadrilateral with exactly 1 pair of parallel sides, so only 1 pair can be parallel. Each of the parallel sides is called the base, and the non-parallel sides are called the legs. So in the diagram that's shown, you've got your parallel marks with your little arrows. So the top and bottom side on this one are the bases. They are not always top and bottom, but they are the parallel ones. And then the non-parallel ones are called the legs. The base angles of the trapezoid are the 2 consecutive angles whose common side is the base. They are where the leg meets the base. So these are a pair of base angles on the bottom. Here, these 2 would be a pair, and these 2 would be a pair of base angles. So they go in pairs. An isosceles trapezoid is a trapezoid that has congruent legs. So the two legs are congruent. They are still not parallel because then it would make it a parallelogram, which it's not. But they are congruent. So two parallel sides, like one pair of parallel sides and then one pair of congruent legs.
Wait.
All right, so then these are all properties of trapezoids that are isosceles. So these are all, well, that one's the reverse of this, but this one is if the trapezoid is an isosceles trapezoid. The first one says each pair of base angles is congruent. So they are, again, in pairs. A would be congruent to D, and B would be congruent to C. Theorem 815 says the opposite. If it has a pair of congruent base angles, then it's an isosceles trapezoid. You only need one pair of angles to be congruent in order to prove it's isosceles. So if A is congruent to D, then it's isosceles, or if B was congruent to C, then it would also be isosceles. And then the last property of isosceles trapezoids is that the diagonals are congruent. You said wait? Okay. So like a rectangle and a square, trapezoids that are isosceles have congruent diagonals. They are not bisected, so they're not, because it's not a parallelogram, they're not bisected, but they are congruent. So the whole diagonal is congruent to the other one. All right, and the last thing about a trapezoid is the mid-segment. The mid-segment of a trapezoid is the segment whose endpoints are the midpoints of the legs. We did this with a triangle. If you remember, we said that the mid-segment was half the length of the third side, and then it was parallel. That's in a triangle. This is in a trapezoid. So again, it connects the midpoints of the sides of the trapezoid.
So it wouldn't be like a vertical?
If the trapezoid was turned, it could be. Like, it's not, the trapezoid's not always gonna have the parallel at the top and bottom. Like, you could have parallel here.
But it only splits the legs.
It has to split the legs, yep. So this would be congruent to this, this to this. And then these would be the parallel ones. Okay, and then the mid-trapezoid, mid-segment theorem, again, specific to the trapezoid, not a triangle, says the mid-segment of the trapezoid is parallel to each base, and its length is 1/2 the sum of the lengths of the bases. So it is base 1 plus base 2 divided by 2, or 1/2 base 1 plus base 2. What's wrong with the trapezoid? What did it do with you?
They're so weird looking.
So this is the same as that. These are the same. Add the base 1 and base 2 and divide by 2. So you'll use this to either find the length of an actual mid-segment, or it might give you the length of the mid-segment and you're using it to find the length of one of the sides. All right, last quadrilateral is a kite. And a kite is a quadrilateral with, God bless you, exactly 2 pairs of congruent consecutive sides. So in this one, the congruent sides have to be one after the other. All 4 cannot be congruent. That makes it a rhombus, and a kite is not a rhombus. So it'll have 2 pairs that are shorter than the other, 2 sides that will be the same but shorter than the other 2, basically. If you picture like a kite in the sky, like an actual kite, that's the shape of this. Yeah. You're after this kid. So this is kite ABCD because this is congruent to this, and this is congruent to this, and again, they are one after the other, not across from each other. That would make it a parallelogram, which is not a kite. Properties of kites. The first is if a quadrilateral is a kite, then its diagonals are perpendicular. So like a rhombus and a square, it has perpendicular diagonals. And if a quadrilateral is a kite, then exactly 1 pair of opposite angles are congruent. And they are it's the pair where the 2 non-congruent sides meet. So where one length and the other meet, not where the 2 congruent sides meet. So it is always going to be, like I could turn it the other way. And if this is congruent to this and this is congruent to this, then the congruent angles are those. The ones where the two different sides meet. The others will never be congruent. Again, that would make it a parallelogram, and a kite is not a parallelogram. All right, now we apply it all. So what shape is this? A trapezoid, specifically a isosceles trapezoid. What's true about an isosceles trapezoid's angles?
Like angle, the base angles are equal.
Okay, so this, if C is 100, which other one is 100? D. So then how could I find A? Why is it 80? And more than one way. Okay, all of them have to add up to 360, so I could subtract the 200 from the 360 and divide by 2, or?
Because
Consecutive interior angles. Good. So those are also parallel, right? So these have to add up to 180. Both of them, both ways would work.
Why is it 100 again?
Because it's isosceles, and isosceles trapezoids have congruent base angles. So where the leg hits the base, those two match. All right, what shape is this? Same.
Actually, do the same procedure with them also.
Okay, this would also be 49, right? And then how do I find F?
180 minus 49.
Which is 131. Easy stuff, right?
Yep.
Example 3. What shape is this? Still an isosceles trapezoid. KB is 21.9 and MF is 32.7. Find FB. How do you find it? Yep.
Try. Oh wait.
So this whole thing is 32.7.
Divide by 3.
Nope.
Isn't it 32.7 minus 21.9?
Why?
Because the diagonals are equal.
Good. So that whole, like either that, I could go that way,
I thought.
or you could go this way, right? Those are equal, so that whole thing is 32.7, which means both of these little parts are the same. So 32.7 minus 21.9. And you get 10.8.
Wait, what? Wait, why is 121.9 and 132.7 again? They're not equal?
The 21.9 is just this part, where the 32.7 is this whole side.
I'm gonna exempt.
All right, now we have a what?
Kite.
A kite, and I know because it's in the instructions, so it will either say in kite like it is in the directions, or it will actually be labeled with your congruent sides, okay? Matthias, you have a question? Okay, so in kite, A, B, C, D, angle DAB. Okay, angle DAB is 54 degrees, and angle CDF is 52 degrees. It wants you to find the measure of angle BCD. Go ahead, Santi.
So like basically a little triangle in there, so you do add 52 and 52, and then you do.
So you're talking which triangle? This triangle? Wait, which triangle? This triangle or the little triangle here?
No.
The big triangle, like CBD, okay, is what kind of triangle?
Isosceles.
Why?
2 of the sides.
These two are the
2 of
same.
the angles.
Good. Two of the sides are the same, so it's isosceles, which makes those angles.
Add them together,
Okay.
and then you subtract 180 minus 180, and then you get.
And that's that angle. Now what? That's the whole angle, right? Does it want? Oh, it does. Sorry, I marked the wrong one. It wants BCD, so that's the angle it wants.
It does.
Thank you. Anybody do it differently? Because you can do it differently. You could have used the small triangle. So if you use the small triangle, this is also an isosceles triangle. Okay, or no, it's not an isosceles triangle, sorry. But you know that these are perpendicular. So you could subtract it from 90 to get that half and then double it to get the 76. Wait,
So he's like,
but wait, there's more.
No, there-
Yes, there is. Okay. If you want to take a picture of that, if you want me to zoom in one at a time, I can too, but So the first one says find the length. I'll zoom out in a minute. Listen, you guys are. All right, find the length of the midsegment of the trapezoid. So in this time, you're given 2 of the bases. Yes, how do I find the midsegment? Add them together, divide by 2. 10 plus 18 divided by 2. 28 divided by 2, which is 14. In the second example, so you might see this with like an expression. Obviously, if it said like x plus 3 and it said 2x plus 5, I would add those together, divide them by 2 to solve for a midsegment. So that's how you could see the algebra brought back in on that one. For the last one, this time you're given the base and the midsegment, but you're not given the second base. So the long way around is base 1 plus base 2 divided by 2 equals 1 or 18.7, and then solve. So if I wanted to solve this, what would I do first? Jonathan? Not divide by 2. Multiply by 2. So these would cancel. 11.5 plus B2 would equal an 18.7.
37.4.
Thank you. And then I would subtract the 11.5. Okay, that's one way to do it. Another way to do it, which I think is probably easier, is figure out what the difference is between these two. So 18.7 minus 11.5, which is 7.2, and then add that on to the middle one. So you could do it either way. If it was the bigger one that was given, obviously I would find the difference between the middle, the midsegment and the big one, and then I'd have to subtract it from it. Questions, because you're going to get questions like both of those in the homework. Everybody's good?
Can you go back to the first one?
Mm-hmm.